Chapter 24, the topic is amines. What are amines? We know ammonia, the nitrogen is bonded to 3 hydrogens. If you replace one of the hydrogens with an R group, it is a primary amine. If you replace a second one also with R group, it is a secondary amine. If you replace the third one also with the alkyl group, it is a tertiary amine. The R groups, generally alkyl groups or aryl groups. Suppose if we take actually a primary amine, an example, this is a primary amine. In this case, the nitrogen is bonded to 1 carbon. So you can take it that way also. How many carbons in nitrogen is bonded to and classify them. We classify amines into 3 types. Based on what? Based on the number of carbons bonded to nitrogen. If the nitrogen is bonded to 1 carbon, it is a primary amine. If the nitrogen bonded to the 2 carbons, it is a secondary amine. If the nitrogen is bonded to 3 carbons, it is a tertiary amine. I have a problem here. We can solve it quickly. Look at the nitrogen is bonded to a carbon here, 2 carbons, so it is a secondary amine. In this case, the nitrogen is bonded to 3 carbons, so it is a tertiary amine. I have more examples here. This one nitrogen is bonded to 1 carbon, so it is a primary. Here the nitrogen is bonded to 1 carbon, so it is a primary. What about here, the third one? The nitrogen is bonded to a carbon here, so you may write it as secondary. It is wrong. Why? The carbon on the double bond should be considered as equal to 2 carbons. So if you actually look at it, 1, 2, 3, so it is a tertiary amine. What if there are 4 groups on the nitrogen? 4 groups. It is not an amine. It is a salt. The name of the salt, not particular name, the group name is quaternary ammonium salt. Some people shortly write it 4th degree salt. I have 2 examples here. In the first one, the nitrogen is bonded to 4 carbons. If a nitrogen is bonded to 4 groups, it will be positive because nitrogen's valency is 3. If it has 1 more group, it is always positive. It is a cation. And you will see an anion, chlorine or something hanging around it. Together, it is a salt. We call it as a quaternary ammonium salt or 4th degree salt. Look at the second example. In this case, nitrogen is bonded to 3 carbons and a hydrogen. Still it is bonded to 4, so it is positive, and there will be a negative ion there. So this is a 4th degree salt. The next naming of amines, how to name an amine. We are going to have a method for primary amine. In fact, 2 different methods for primary amine. And we will have a different method for secondary and tertiary amines. So first topic, how to name a primary amine. Primary amine contains, just for example, this one, contains only one alkyl group. You can name that alkyl group and add the word amine. Look at it here, I have some examples. This contains 4 carbons in a straight chain, 5 carbons. So that is a pentyl group. So I can write the name of the pentyl and add the word amine, pentylamine. There is another way to name the same primary amine. Instead of actually naming that as an alkyl group, name the carbon chain or the ring if you have as alkane. And if you name the alkane 5 carbon chain as a pentane, and you replace the E with the word amine, pentanamine. So this is a second way for naming primary amines. So this has 5, so you can call it as pentanamine. I have one more example here. If you use the alkyl group, this alkyl group, it is a cyclohexyl group, so you can call it cyclohexylamine, and these are substitute on it. This is carbon 1, 2, 3, 4, 5, 6, 4,4-dimethyl cyclohexylamine. If you name that ring as an alkyl group, if you name that ring as an alkane, it's a cyclohexane. I replace the E with amine, cyclohexanamine, and then again 4,4-dimethyl. How to name as secondary or tertiary amine? In secondary, you have 2 alkyl groups. In tertiary, there are 3 alkyl groups. If the alkyl groups are the same, it is a symmetrical amine. Look at it here. There are 2 alkyl groups, both of them methyl. That is the way, even in tertiary amine, there are 3 alkyl groups, they are all the same. So these 2 are examples of symmetrical amine. If they are not the same, that amine is unsymmetrical amine. How to name a symmetrical amine? Just to name the alkyl groups, add the word amine. In this case, you have 2 ethyl groups, so it is a diethylamine. In the second one, there are 3 ethyl groups, triethylamine. Pretty easy. If the amine is unsymmetrical, how to do that? Compare the alkyl groups. Select the largest alkyl group and name it, and then add the word amine. Name the other alkyl groups as substituents on nitrogen. For example, in this one, the largest group is this. It is 1, 2, 3. So propylamine. Write the propylamine. The propylamine must have NH2. But in the place of hydrogen, it has a methyl group, so N-methyl propylamine. In this case, the largest one is a cyclohexyl group, so add the word cyclohexylamine. But the nitrogen, the cyclohexylamine must have NH2. But someone took the hydrogens off and put the ethyl and methyl groups. They are substituents on the nitrogens. So N-ethyl and methyl cyclohexylamine. Heterocyclic amines. We saw some heterocyclic compounds in chapter 16. You know what they are. For example, if you look at cyclohexane, the ring is made by carbon atoms. It's a homocyclic ring. Or if you look at the benzene ring, it is made by carbons, no other atom. If the ring is made by just carbons, it is homocyclic. Even if one carbon is replaced with an oxygen or nitrogen, the ring is made by more than one kind of atoms. It is a heterocyclic. Some amines are heterocyclic compounds. Unfortunately, IUPAC allows their common names to exist. So I have some of them. Some of them aliphatic, they are not aromatic. Heterocyclic amines, so look at them. They contain some nitrogen bonded to the carbons. They are all amines. The name of the first one is preludin. Second one is piperidine. Third is piperazine. This is morpholin. Some aromatic heterocyclic compounds are also amines. Look at here. These are all aromatic compounds. We saw them in chapter 15. Heterocyclic aromatic. The name of this is pridine. This is pyrimidine. The third one is pyrrole. And you have more names here. Imidazole, quinolone. But it is hard for you actually to remember the structure and memorize the names. So just to look at it, these are, if that is absolutely necessary in future, you just to look at the book, to look at the name, because to memorize the structure and the names are hard. But these are all good sounding words: piperidine, piperazine, morpholin, pridine, pyrimidine, pyrrole, imidazole, quinolone. In case if you get a girl in the future, you want some names, you can pick up some names from here, show your organic chemistry talent. Structure of amines. The nitrogen in amine is an sp3 hybridized. So it should have a tetrahedral shape. Unfortunately, it has only 3 bonds. One of them is lone pairs. So if you look at the electronic shape, it is tetrahedron. But if you look at the 3D shape, this is trigonal pyramid. We learned it in chapter 1. You may remember or may not remember it. So if the 3 groups on the nitrogen are different, for example, look at this amine. I have an R group, R prime, R2 prime. They are all different. If you consider the lone pair as a group, this is a chiral nitrogen. If the 3 groups on nitrogen and amine are different, nitrogen is chiral. If there is one chiral, you know how many stereoisomers? 2 to the power n. N is the number of chirals. So in this case 1, you must have 2 stereoisomers. 2. One is this one, the other one is its mirror image. So the amines actually which has a chiral nitrogen will have 2 isomers. Normally we saw in chapter 5, you need not go back and look at it, but you know there is 2 isomers. One is the mirror image of the other, but not superimposable. We call them enantiomers. So these 2 are enantiomers. They are mirror images, not superimposable. But we also saw in chapter 5, if you have this kind of the structures, two structures which are mirror images, non-superimposable, one will have R configuration, the other will have S configuration, and we can separate them. But in this case, you cannot separate it. Why we cannot separate it? Because there are three groups on it. One is a lone pair. The separation, this conversion into this one goes through this transition state. It flattens and inverts. So as a result, what is happening here, even though this and this are the mirror images, non-superimposable, in this case, these are interconvertible. They convert themselves very fast one into the other, so you cannot separate it. You know they exist, but we cannot separate them as we did the other compounds in chapter 5. What about the structures of the quaternary ammonium salts? In those, that nitrogen is bonded to 4 groups. If the 4 groups are different, in this example, they are different. One is hydrogen, the other is R group, R primer. This is a chiral nitrogen. And it will have 2 stereoisomers. One is the mirror image of the other. But we can separate these two because they don't interconvert one into the other. So this is the end of the first video.